Delisu87. Does Starship have an escape capability for crewed versions? If not, isn't that a major flaw? So Starship does not have a method that the crew can escape during a during a flight. That unlike, well, it's more like the space shuttle, really, in that, so let's talk about sort of the other kinds of ways that humans can go to space. So you look at, for example, Crew Dragon. Crew Dragon sits on top of a Falcon 9 rocket, on top of the upper stage of the Falcon 9 rocket. When the rocket takes off, if there's any problem with the rocket, then the crew capsule has its own propulsion system on board that allows it to escape from the explosion of the rocket underneath. And in fact, the Orion capsule has the same thing. The Orion capsule has this really cool, almost like a tower on the top of the capsule that can fire and pull the capsule away from the explosion very rapidly. And so this was a huge requirement when NASA was developing the commercial crew with its partners, with Boeing for the Starliner and with SpaceX for the Crew Dragon, that they needed some way to be able to get the crew off of the exploding rocket. And this came as a direct result of what happened with the Challenger accident back in 1986, that there was definitely a problem with the rocket. You had this explosion that was happening, and the crew had no way to be able to escape it. Now, with the space shuttle, what they did was they went back and said, okay, how can we just give the crew a way to get off of the shuttle if it's breaking up and if there's some problem? And the solution was very rudimentary, kind of scary, which was that the crew would deploy a pole outside the space shuttle. They would open up a door, and then they would use this pole to kind of push them. They would sort of slide down the pole to get out away from the space shuttle, and then they would be able to parachute to safety. And it never was required, it was never used, but this was the method of egress that NASA had come up with. And you can just imagine, the space shuttle is tumbling, there's a fiery explosion underneath. The chances that the crew would actually be able to get out and onto this system would be very low, but it was better than nothing, and that was sort of enough that was required for them to be able to push forward. And in the end, the second major accident that happened with the space shuttle was with Columbia in 2003, when there was debris that happened on the space shuttle's wing, and then when it went to space, and then as it was coming back down through orbit, then hot gases made their way inside the shuttle and tore the shuttle apart, and there was just no way that the crew could get off of that. So you kind of have this terrible lesson that NASA is trying to learn. And so they make crew escape a really important part of this process. And in fact, this is across all the rockets. The Chinese do this with their new crew capsule system. In fact, they just tested it just a couple of weeks ago. The Russians do this. So this is, keep the crew safe at all costs is the goal. So the problem, of course, is that SpaceX Starship does not have this system on board. You've got the Super Heavy booster, and then you've got the Starship that is stacked on top of that. And there is, no crew module that sits inside the Starship that is a way for the crew to be able to escape from the spacecraft when this is happening. But, Elon Musk has said that the Starship itself is the crew escape vehicle. That if there's a problem with the Super Heavy booster, they can kick on Starship, they can detach from the Super Heavy booster and carry Starship away from the booster. And, that is definitely one improvement over just no ability to escape at all. But it's a big ask. You're trying to accelerate this gigantic skyscraper away from this other exploding skyscraper, and you're looking at challenges. And so I think in the short term, very few organizations are going to be willing to put human beings on board Starship, because the exit, the flight, and the reentry are both going to be just these incredibly dangerous, risky operations that you just wouldn't feel safe putting human beings on board. And I don't think you need to. You know, the Crew Dragon is now this really very safe vehicle that demonstrates that it can go to and from space, that it's optimized not for cargo, not for launching satellites, not for doing all of these other jobs. It's optimized for carrying humans to space. And, you know, we're waiting for Starliner to work, you know, to go through all of the acceptance process, and hopefully it'll be in that same camp. And there are other potential systems that are going to carry humans to space. And so I think for the longest time, until people are incredibly confident at the safety and stability of the SpaceX Starship, that you're going to see people go to space on Crew Dragon, on the Orion capsule. Then they'll meet up with Starship in space if there is some kind of living quarters on board, and then they'll use that to go to Mars. So I wouldn't be surprised that kind of the future architecture is people fly to space in some very safe, crew-specific vehicle, go to a space station, wait on the space station, Starship launches, docks up with the station, and then takes them to Mars or whatever. But, you know, if we go 100 launches, 1,000 launches, and there's never a single explosion on ascent, there's never a single destruction on reentry, then people start to push towards, okay, well, maybe Starship is safe enough for us to be able to put human beings on board. But like, would I get on Starship? No. Would I get on a Crew Dragon? Yes. So I think, you know, this is a decision that the space agencies are going to have to make. Now, this is just sort of my shorter version. Tim Dodd, the Everyday Astronaut, did a fantastic deep dive into this, and I think he even posed questions to Elon Musk about this. So we'll put a link in the show notes. So if you want to sort of watch that much longer deep dive into why Starship doesn't have a crew escape system, check that out. Okay, awesome. So that was the first question, and now we're gonna kick into sort of more of the administration here for a second. So, hey everyone, thank you for joining me. This is our live question show that we do every Monday here on the channel, and so I'm going to be answering your questions about space and or astronomy or whatever live, and then we will chop this episode up, and this becomes the edited versions that you see here on the channel. So we've got the question shows. We launch 2 question shows every week. Launch. I'm such a rocket nerd. Okay. We deploy. Right, anyway, so we will post 2 question shows here on the channel every week. And then we also post 2 additional, what we call overtime episodes over on Patreon. And together, the 4 episodes are the 2 hours that this live stream is going to become. Now, a few ground rules. Go ahead and put any questions that you want into the YouTube comments. It's very important for me to be able to notice that you have asked a question, that you put a question mark and you use some of the, who, what, where, when, why, how tags, So if you pose a question, but it doesn't look like a question, then I'm probably not going to notice it as a question. Now, I try to give emphasis to the people who've never had a question answered before and what I mean by that is that we have not actually, I gotta record that. There's my downside. Okay. So I give emphasis to the people who have never had a question answered before. And so that means that, if you've asked a question in the live stream or in the YouTube comments, and then it shows up in our question show that we post on the channel, then, that's a vote for you. And I try to give emphasis to the people who've never had those questions answered before. Keep in mind that I am a journalist, not a scientist. And so I cannot provide you an opinion about scientific matters. I will gladly give you opinions, but I really try to focus them on things that I am familiar with and comfortable with. So, my job is to communicate the scientific consensus. And if the scientific consensus bothers you, if me saying that the thing that you should trust is the scientific consensus, I just want to warn you right now, this video is not for you. Like, there's plenty of other channels out there that are going to push against the scientific consensus, mavericks who are going to consider and do their own research. And that's not me. I am a journalist, just trying to take what scientists are working on and try to communicate it to you in a way that helps you understand what they're working on. And then the last thing is that, we get a lot of the same questions here on the channel. And so I will try to try to keep things fresh. So if I don't answer your question, it's not personal. It's just, this is a question we've had a lot before. So, dig deep. Ask questions that you think we've never had before. All right. Let's get on with the questions. Humbug. Any plans to run the live astro sessions again? This seems like a great time with the profusion of automated telescopes like Seastar. Absolutely. And in fact, there's a lot of really exciting developments on that front. So just to sort of give you some history, for those of you who don't know, I used to do this thing called the Virtual Star Party, where I would coordinate with a bunch of astronomers around the world. We would share live streams of the night sky, and we would talk about the objects that we're seeing. We'd bring in experts, astronomers, and we would talk about it. It was great. In fact, I consider it the coolest thing I've ever done. And yet, it was brutal to organize this, that it burned me out. It burned volunteers who wanted to try and help produce this out. I had to sort of stop doing it just because it was just like week after week of, when you think about it, every astronomer has their gear and they have their personal commitments and they have their weather. And if any of those things fail, then they're no longer able to participate in the party. And so sometimes I would have 10 people show up. Other times I would have nobody show up. And it was very inconsistent, and it was just spending an enormous amount of energy, and it wasn't enough energy to be able to overcome all of these hurdles. But we're now in this age where you've got remotely operated telescopes, thanks to companies like Starfront, where you can control these telescopes. I've got a Seastar, I've got the Vaonis Vespera 2 behind me. Both are incredible telescopes, very easy to use. I could put these in the hands of anybody, and they could be able to start doing a live stream of the sky, which is incredible. The problem is that all of these smart telescopes are locked down, that they make it really difficult for me to be able to have somebody have a live stream of the telescope that is streaming to their phone, for example, or to their iPad, or even to their computer, and then to be able to draw that video, that feed into something that I can do as a broadcast. And I have been banging my head against this as a problem. And you have no idea. And so I had sort of found this open API that allowed us to communicate with the Seastar, and I was able to kind of control Seastars remotely through the computer. And so I would be able to have this really cool computer interface that would allow various people to operate the Seastars, and then anybody could join me for the star party. They didn't have to be an expert. I could have someone who is an enthusiast about astronomy, but isn't necessarily owning a telescope. And so that was a much more kind of exciting direction to go. But because these systems are so locked down, and in fact, Seastar within the last month shut down their API access. And so all of the tools that we built to try and communicate with this telescope went offline. And so that avenue was closed down to me. The Vaonis I can't connect to and provide this sort of open API control to. So what I did was I built my own smart telescope, which is that I have an old, not super old, maybe 8-year-old telescope. Like a really nice mount, an Explorer Scientifics mount with a 70mm refractor and an ASI camera. Black monochrome camera, and I developed a completely custom interface to that telescope that allows me to press a button, scan the sky, automatically figure out where it is, plate solve, determine its GPS location, and then I've got a database of objects. You can just pick objects, and the telescope moves around and then live stacks them for doing this kind of live stream. And I'm like 98% there. Like, I was testing it 2 nights ago when I had clear skies, and I hope to have it wrapped up by the end of this week. And then I'm free, right? And in fact, I've got a new color camera coming for the telescope that will look a lot better than the monochrome one that I was using. And so then I kind of imagine, okay, so I can build this layer that I can give to other astronomers and say, hey, hook your telescope up into this system, and then we'll make it very easy to be able to manage and control your telescope. Other people could control your telescope. So people could donate telescope time, and other people could control them, and then we could bring it all together into one telescope live stream, which would be a lot of fun. So I am utterly obsessed with getting this back operational, but with the wisdom of all of the horrible things that happened last time when we tried to make this thing go, and trying to come up with a solution that I'm no longer dependent on the technological whims of some company. I'm no longer having to sort of worry about whether it's too complicated or gear issues, and I will probably be partnering with Starfront, which is an incredible company. They've got this huge sort of co-location telescope system down in Texas where they have clear skies pretty much every single night. They've got tons of room for telescopes. And so we'll start to try and make telescopes available through Starfront, but with this application that I'm building, that allows a really nice interface to it. So I know there's like a lot of words, a lot of empty promises, but I am mark my words, I'm spending hours every day trying to solve this problem once and for all so that I can have a really cool live stream telescope system. And so you're probably going to see a bunch of technical tests that I'm going to be doing over the next couple of weeks, trying to kind of move forward in this direction. And then you'll get a sense of sort of what my larger plans are. So stay tuned. ABC Boxy. My AI wants to know, what's a question you wish people would ask you about the universe, but nobody ever does? Did you seriously ask your AI that you're watching a live stream from Fraser Cain and that you would like the AI to you said, do you want to ask Fraser a question? And the AI asked that question. Like follow-up question, which AI were you using? How did you do this? That's hilarious that it even knows who I am, but okay. So my answer is going to be really disappointing, which is that I am asked so many questions across all of the media that I do. I have tens of thousands of questions that I have answered. Nobody has asked me. I can't even imagine a question that I really wish somebody would ask me that hasn't been asked, that every flavor and nuance of every single question that I have ever thought of has been asked. And in fact, what makes this really special is that I get questions that I had never even occurred to me that I think is such a great question. Like those delight me. And so I literally cannot go, man, I wish somebody would just ask me this question, because we're so far beyond that, right? That we're deep into, people are asking me questions all the time that I'm just utterly baffled how cool they are, gobsmacked. So thanks, AI. Turn the AC on. Okay. Domingo Flav, do you think that deja vu and dreams could be glimpses into our multiverse versions of our lives that we live? So I'm not a biologist, definitely not a neurologist. I have no practice and skill in this, but I think, both deja vu and dreams. Deja vu is something that is it's an actual physical thing. I've experienced it. And I think it's been described as a kind of brain glitch. And dreams are a funny thing, because I've been sort of thinking about dreams and my experience of dreams. And I don't know if this matches sort of your experience with dreams, but you have a dream, you remember your dream, something is happening in your dream, and then you wake up. And so, you're having this dream and then your alarm goes off, or you're having this dream and then you have to go to the bathroom. You're having this dream and then a phone call comes. And generally for me, anyway, I don't know if this is like for you guys, but this idea, you have this dream and then this event interrupts the dream. And yet there's plenty of times when you're almost certainly dreaming and nothing is interrupting the dream. And so you don't remember, you don't experience the dream. And so it feels like dreams are memories. That you wake up and then what you do is you get this memory of the dream that you were having before you were woken up, because they're always tied together. I never just have a dream and don't wake up. And so it feels like, well, what are the chances that you would remember your dream and you would also wake up? And so instead, they're just memories. Is my interpretation, is my experience. But glimpses into multiverse versions, there is no scientific consensus that that is true. Hudson Hensley, can you explain why a gravity balance point between two planets in a binary system is dependent on the planets being exactly the same mass? Wouldn't it be just a little closer to the heavier planet? Well, the thing that happens is any two objects are not okay. So when you imagine, say, a planet orbiting around a star, you sort of see the star as this fixed thing and you imagine the planet orbiting around the star. But that's not true. What's really happening is that the planet and the star are orbiting around a common center of mass, and that it's more like, say, you are spinning around holding a bucket of water and you're having to lean back because the bucket is trying to pull you forward, you're trying to pull the bucket back, and you find this balance point. And the same thing is happening with a star and a planet. And so, in fact, this is how astronomers discover the existence of planets orbiting around stars, is through the radial velocity method. They're watching as the star is essentially wobbling due to the gravity of the planet. Now, when you scale towards something that is similar in size, two planets that are orbiting around each other, or two stars that are orbiting around each other, then the common center of mass is outside of the planets. Like for the Earth and the Moon, the common center of mass between the Earth and the Moon is inside the Earth. And so you can't sit at the common center of mass between those two. You're inside the Earth. But for something like, say, Pluto and Charon, the common center of mass is actually outside of the surface of Pluto. And so there's this balance point, and I use this very loosely, outside of the surface of Pluto that you could hover at with a sort of with less fuel than would be required for you to be in any other place in their position. And so the same thing goes. You just need to find the common center of mass of the two objects that are orbiting around each other, and then that would be the place that you could go, kind of like a Lagrange point, where you could use less propellant to be able to maintain in that position. But we have very few of those here in the solar system, like really just one. I guess like maybe there are probably asteroids with moons where the common center is outside of the asteroid. But for all the planets, for the sun, it's all inside the larger object. Jay Peterson, SpaceX wants to launch 1 million satellites using a mass driver on the moon. How would those satellites circularize their orbits? Wouldn't the g-forces of a realistic mass driver break regular rockets? So that is a great question. And this is sort of like a nuance on this idea, and sort of give people a little bit of background. Elon Musk has changed his mind and no longer wants to make Mars the first priority for human exploration, wants to start with the moon. And one of the key components of this sort of moon first strategy is that you're going to build this city on the moon, and that moon city is going to be building artificial intelligence data centers on the surface, and then it's going to be launching them into orbit using a mass driver. And this idea of a lunar-based mass driver is not crazy. Using mass drivers on Earth is just borderline crazy, because the energy levels involved will tear the mass driver apart every time you try to launch it, and the atmosphere is so thick that anything you launch at those kinds of velocities will ignite, and turn into essentially re-entering the Earth's atmosphere from the bottom at the thickest part. But once you're on the moon, you have no atmosphere, the surface gravity is dramatically lower, and it is theoretically possible with the kind of technology that we have today to be able to launch stuff off of the moon purely through electricity. There's tons of solar power available on the moon. The surface of the moon is made of metal and rock and oxygen. So you've got silicon, you've got oxygen, you've got titanium, aluminum, iron, all of these minerals sitting there on the surface of the moon that you can just access to turn into the kinds of things that go into into not computers necessarily, but definitely can go into the solar panels, the kinds of infrastructure that you would need for a satellite. And so then they would probably send chips from Earth, send the actual processors from send the processors from Earth. Down the road, they may actually build chip fabs on the moon, but who knows? And then they would build the actual satellite on the moon, and then they would deploy it on this mass driver, and they would send it away. And so the trick is that, yes, if you wanted to make a satellite that was going to go into orbit around the moon, then you would need some way to circularize its orbit. Because essentially, if you can't circularize the orbit, then any single kick is going to bring this object back down to hit the moon. But if you send it greater than the escape velocity of the moon, then the object goes into Earth orbit. And so now it's orbiting around the moon in kind of the same way that the moon is orbiting around, and now it's orbiting around the Earth in kind of the same way that the Earth is. Just one more time. And so now your satellite is orbiting around the Earth in the same way that the moon is orbiting around the Earth. If you give it an even higher velocity, then you're putting it into solar orbit. And so now it is orbiting around the sun in the way that the Earth is orbiting around the sun. If you give it even more velocity, now you're putting it into escape velocity from the solar system. You're essentially putting it into Milky Way orbit, and you sort of keep going, right, with more and more velocity. And so you could put stuff into orbit around the Earth. And in fact, this is sort of the idea of the O'Neill cylinders back in the 1970s. They were sort of thinking about how you could build giant space stations at the L4, L5 points of the Earth-Moon Lagrange system, and you would be using mass drivers to launch material off the surface of the moon up to L4, L5, and then they would be collected together and turned into these giant stations. Now, you probably still want some kind of propulsion system on board your spacecraft to be able to handle the, to be able to reposition itself, move it, avoid objects, things like that. So you don't need like a full-on big rocket, but you're probably going to want an ion engine like the SpaceX satellites have. But then you're very far away from the Earth. And so communication time from whatever orbit you're on to go all the way down to the surface of the Earth is going to take you a while. And that maybe people are going to want these AI satellites closer to the Earth. I don't want them closer to Earth, but people might want that. And so then they are going to need more propulsion to get closer and closer to the Earth, because it's actually difficult to sort of decrease your orbit. It requires a lot of fuel to be able to get into orbit around the Earth again. There's something else I was going to say on this. Okay, right. And then the question you're asking is about the forces involved. Like, will a rocket be able to handle the launch force of this? And so you would be amazed at how much force just a pure folded up satellite could handle. Much more force than a human could handle. And so if the force is too high and you think you're going to be smashing your satellites as you're accelerating them with the mass driver, then you make the runway longer. It's like maybe you find a mountain that is several kilometers high and you run your mass driver up the side of that mountain, getting faster and faster and faster. And at no point do the forces exceed what your satellites can handle in terms of that force. So this is an engineering challenge. And like, I want to just be super clear that all of this is like borderline science fiction, right? That building a city on the moon, really hard. Building mass drivers on the moon, really hard. Building the technological infrastructure to do all this, incredibly expensive and really difficult. And the only thing that makes it seem like, okay, maybe this might be possible down the road is just the enormous amount that the AI companies are spending to invest in their AI data centers here on Earth. They're spending hundreds of billions of dollars. It's expected by the end of the decade, they'll be spending trillions of dollars every year just on their AI infrastructure. And then, these like 100 billion here and 100 billion there to set up a city on the moon, if the economics make sense, actually isn't that crazy. So we're in a very unusual time in human history And it may very well be that a use case for space exploration, for space industrialization has been invented, has been developed, and that this might be the thing that kicks off that solar system spanning civilization. Or it's a huge, AI crash that's just around the corner, and all these companies are going to lose money, and we're all going to get super cheap GPUs any day now, and we can all just live in gutted out data centers and put our skate parks into these gutted out data centers. So who knows what's going to happen? It's pretty fascinating to watch it, and terrifying. Adam Redwine, what percent of the universe's total lifetime has already passed? Well, the universe is 14.8 billion years, and so that's the amount of time that has elapsed. And in fact, when you think about the potential future of the universe, there's no reason to believe that it's not infinite. And so, if you divide infinity by or does it go the other way around? Anyway, if you consider what is this as a fraction of infinity, then the answer is undefined, because infinity is infinity. Now, you can ask you can ask more specific questions, like, what percentage of the universe's time of increased amounts of star formation have we gone through? And that's actually long gone. That the point when the universe was going through the most active star formation was about 2 billion years after the Big Bang, and that it has been decreasing up until that point, or it has been decreasing since then. We are now having less star formation than we did 12 billion years ago. But we are still in the age of stars. And so you could also say, well, how long will stars last? Well, probably the last star is going to form within the next few 100 billion years from now. And then, so what are we, just a few percentage into the age of the last, 10% maybe of the last stars forming. And then you can say, well, how long will the stars live? And the smallest red dwarf stars could potentially last for 10 trillion years. So now we are just a thousandth, we're thousandths of a percent of the potential lifetime of that era. But then you're still going to have the black holes. The black holes will evaporate, and that is 10 to the power of 100 years. And so that is now, the numbers are very, very small. But it is entirely possible, if the heat death of the universe is the way that things look like they're going to happen, there is no reason to believe that this universe will ever stop, that it'll just become this smooth distribution of particles that are all the exact same temperature, just above absolute zero, and nothing interesting is ever going to happen for that infinity. So be glad that we're around at the time that we are now. Sorry, just looking at questions. Hudson Ansley, how is Fraser versus deer going? Yeah, so I have an orchard that I've surrounded with a willow fence that I've been building, and we're now 3 years into the willow fence, and the deer have not come in so far, but I think that's just because there's nothing interesting on the trees yet. I'm doing everything I can to harden the fence for the coming battles, but we're actually building a new garden, just a pure straight up vegetable garden. And this one I'm not going to bother. We're building treated wood posts, 6.5 foot line wire fencing, solid gate. It will be pre-deer proof. But my idea, and I got approval from the wife on this, is that I will then weave willow branches down through the wire and put them into the ground. And so in the next couple of years, the fence will look like it's willow, but in fact, it's got a wire inside of it that will stop the deer from coming in. And then I can imagine some future where I would very slowly and carefully pick away the wire, cut out the wire and remove it if I really want to, but I'll probably just leave it in forever. So I'm sort of evolving my strategy. I would say the deer won. The deer do what they want. And my pathetic attempts to stop them are meaningless to them. And I only exist by, because they allow me to. Deer are just deadly. Do not mess with them. Ed Skeptic Y2, is biological life the exact opposite of entropy? And what does that mean? So I've actually got an interview coming up in just a couple of days, maybe like today, but definitely this week, where we cover this exact thing, which is that I talked to a pair of authors who, one is a geologist, the other is an astrobiologist, and they've written a new book called Time Second Arrow. And the gist is that in addition to entropy, there appears to be a kind of complexity of information that is happening in the universe as well. And so we're seeing evolution, we're seeing mineral processes get more and more complicated over time. And so there might actually be sort of two forces that are working in tandem with each other throughout the age of the universe. And so I think this will answer your exact question. So stay tuned for that interview in just a couple of days. Sora Cloud, is Parker doing well? If so, in theory, do we have the technology and capability to build the starting tech for a Dyson sphere? Yeah, Parker Solar Probe is performing exactly as expected. It's now reached its final orbit. It has no more flybys that it can do of Mercury or Venus to be able to move it any closer to the sun. And so it's sort of in this final orbit that brings it really close to the sun. It's gathering a bunch of information and then flies back out and then dives back in, cools down to get far away from the sun, and then dives back in and heats up. And, it will operate for the rest of its primary mission. And then the NASA will take a look at the health of the spacecraft and decide how well it's doing and then continue on this process. When it's out of propellant, which is usually kind of the death knell for all of these kinds of satellites, then they will do something that's really interesting, which is that they're going to then turn the spacecraft so that its heat shield is no longer protecting all of the instruments. And then they're going to let the radiation and the heat from the sun start to ablate the instruments on board the spacecraft, destroy them, and keep track of what happens to the instruments as they're getting ablated, how long they last, what kind of radiation tolerance can they have. And that will allow future spacecraft that will be in sort of high temperature environments. They'll know what the various metals, the glass, the instruments can handle across the entire spacecraft. And then Parker Solar Probe will be a burned out husk that will be continuing to orbit the sun for forever, really. It'll be the heat shield will be all that's left. So, is this the starting tech for the Dyson sphere? Well, I always say that we've already begun building our Dyson sphere, that every satellite that we launch into space that is harvesting energy from the sun and is doing some kind of work for us, be it science, be it communications, be it human habitation, whatever it is, this is the Dyson sphere, right? We are preventing radiation that would have gone out into deep space, that we are now collecting it and capturing it here for our purposes, either using it in space to run the operations of the spacecraft, or we are bringing it back down to Earth. It's just a matter of scale, right? And so every year that goes by, we will have more satellites. We'll have more satellites, for sure. Right now, whatever, there's 1/4 of the sun's energy is being blocked by machines from humanity, but maybe next year it'll be 2 quadrillionths, and maybe in 100 years it'll be 1%, and then in 1,000 years it'll be 10%. And so you don't just go, now we're building the Dyson sphere. It's more that you just build more and more satellites to harvest more and more of the radiation that's coming from the sun. In the same way that you look at a forest and say, you know, if you're harvesting for if you're harvesting the lumber from a forest, you cut down the trees one at a time until you've cut down the trees in a responsible way, making sure that they're wildlife corridors and you're not infringing on the riparian habitats with a sustainable forestry system. But yeah, that's how it goes. So I think, you know, the Dyson sphere has already begun. The moment we launched a solar powered satellite, and I wonder, was the first solar powered satellite? That's interesting. The Dyson sphere construction began. Ragetail. Is the idea of adding a slingshot connected to Earth for slinging rockets to space a realistic idea? Yes, but I sort of have to just sort of qualify this in a whole bunch of ways. So to carry stuff out of the Earth's gravity well is a very special problem. You've both got the enormous gravity of the Earth that you're having to overcome, but you've also got the atmosphere that you have to be able to push through. And both of those forces come together to make rocketry a very complicated matter. And this is why ideas like space elevators or mass drivers or spin launch or, you know, any way that you're going to try to just hurl objects into space has so far not been successful. The system that actually does work is that you stack up a skyscraper filled with explosive chemicals, and then you control the explosion long enough to get the whatever cargo you're trying to get into space safely. And it's always like almost like a miracle to me that this even works, that we have the technological capability to mix various chemicals together, control the explosion, direct it out of the rocket engine, and actually have this thing potentially be reusable. It's bananas. But the goal has always been, or the dream has always been, like, how can we do this without having to have rockets? And there've been plenty of ideas that have been proposed, and at the end of the day, rockets just kind of get the job done. But once you're out in orbit, then a lot of those challenges start to go away. Now, you imagine you're in low Earth orbit around the Earth, and you're trying to get away from the Earth. And so you're trying to go on higher orbits. And so you can use your rocket, fire the thrusters, that carries you higher, farther away from the Earth, and you can circularize your orbit and so on. And so people have been proposing interesting ideas for that. And the one that I really like is a rotating tether, which is kind of like what you're talking about. And so what you do is you have this tether that has a sort of center of mass at the middle of it. And then you've got hooks on both sides of the tether. And the thing just sits in Earth orbit and just rotates around, waiting. And then you launch some payload on a rocket. The rocket reaches low Earth orbit, say you're about 500 kilometers in altitude, which is, now you've done all the really hard part, but you still want to go to a higher and higher orbit. You want to get close to the moon, for example. And then you release your payload. The payload attaches to to one of the hooks and then gets carried all the way up to the top part of its rotation. And then it gets let go. And so now you've raised the orbit of this payload, the length of the, not only the length of the tether, but also just the additional sort of kick you get from the rotation of the tether. And so this can raise you. And then you can go and do another one and another one, and you can raise yourself multiple orbits, theoretically completely out of Earth orbit. It just requires this incredibly careful maneuvering to make sure that each time you release a payload, it gets caught by the next tether and is raised to the next orbit. And each time that you do this, the tether drops its orbit a little bit because it's essentially giving up that orbital momentum to the payload. But you can use, say, a solar sail, or you can use very efficient ion engines on the tether to have it raise itself back up to be prepared for the next payload that's going to come. So it's a very technically complicated, a lot of moving parts, but it is as close as we're going to get to an almost free lunch to be able to raise payloads higher and higher. And when you look at, say, the payloads that you can carry to the moon, it's a fraction of what you can launch to low Earth orbit. Like the moon, like it feels instinctively that once you're in orbit, then you just kind of drift to the moon. But it is not like that. The moon is at the top of a mountain that you have to continue climbing. When you get into low Earth orbit, you've only begun to climb. You still have to climb all the way up to the top to get to the moon. And so you can launch a fraction of payload to the moon that you could launch into low Earth orbit. And so people are always looking for ways that you can continue that journey up the gravitational well out of Earth orbit. Oh, there you go. Zapvan says Vanguard 1 was the first satellite with solar panels in 1958. So, man, that's a video I should do, right? That we began the Dyson Sphere in 1958. I love it. Lothian, is it really a Dyson Sphere? It does not provide power to Earth? Yes. Yeah, why does the power have to come to Earth? If you're going to build a satellite that's going to be doing computing, that's going to run enormous simulations that are going to be trying to work out cures for cancer, things like that. You send the raw data up to the satellite crunches all the data for a year, it sends you the result back on Earth. How is that not just an extension of our civilization into space? So yeah, I think very little of the future of really just the solar power that's coming from the sun is going to be used down on the surface of the Earth. And the reality is that you don't want to. That every photon that you send from space to Earth contributes to the warming of the planet. And we already have seen with global warming how, just by trapping carbon dioxide in the atmosphere, we are warming the planet. We do not want to compound this with sending additional photons from space down to Earth. We can send information, we can send finished components maybe, but really we're going to be sending stuff to space that's going to be used in space for space things. And maybe these satellites are going to be beaming power to each other, but we definitely don't want to send any of this back down to Earth. And in the sort of most advanced version of the Dyson Sphere, you've destroyed the Earth as well, right? Like, to make your Dyson Sphere, eventually you dismantle Mercury and Venus and Jupiter and all these things to fully control. And maybe people are going to go, well, do we really need Earth anymore? Yes, you need Earth. Don't do it. Don't destroy the planet to build your Dyson Sphere. You're bad people if you do that. But this is a thing that some future civilization might decide they want to do. Jack Ray, what magnification level and lens size would be good for binoculars used to stargaze? So I like, okay, so you can use pretty much any pair of binoculars to stargaze. Even just that crappy pair of binoculars has been sitting around your parents' house that they haven't used for a long time. Those are pretty good. The kind of default set of binoculars, the ones that most people have, are a 7 by 35. That's a very common size, where 35 is the size of the lens on the binoculars. And just to give you a sense, the Sea Star that I have has one 50 millimeter lens. And so just a $50 pair of binoculars that you can pick up from Amazon, the combined light of the two lenses is more than a telescope that I have. Combined, it's more than both telescopes that I have. And they work great. You go outside, you can see if there's a comet in the sky, you can use the binoculars to see the comet. You can look at star clusters, you can look at the Milky Way, you can see things like the globular star cluster in Hercules. You can see you can even just barely make out, say, the moons of Jupiter when Jupiter is at its closest point. Maybe just make out the rings of Saturn with just a regular pair of binoculars. And you can use them for bird watching and so on. But if you want to get serious, then I recommend that you go to a pair of binoculars that's specifically designed for astronomy. And the ones that I always talk about, not sponsored, you're welcome, Celestron, are the Celestron Skymasters. And I have a pair of 15 by 35s. So 15 times magnification, 15 by 75. Yeah. So what I have is a pair of 15 by 75 Skymasters. And so that is a 15 power magnification from the binoculars with 75 millimeter lenses. And now those are bigger than any telescope that I have except for this one, right? So they're big, and yet they're relatively inexpensive. I've seen them on sale for less than $100. I'm sure you can pick them up used for relatively inexpensive. And they're by far the most commonly used piece of astronomy gear that we have in the house for both me and my wife. Every night that Jupiter is up, I take the binoculars out and I take a look. Saturn is up, I take the binoculars out and I take a look. And that's enough. 15 power, then you're seeing the rings of Saturn, you're seeing the moons of Jupiter, you're seeing comets, you're seeing star clusters, you're seeing the Andromeda galaxy, you're seeing the Orion Nebula. It opens up a whole new level of the sky. And what I really love about binoculars is that it still makes you learn the sky. That, the binoculars are useless if you don't know where to look. Well, the way you look is you learn your stars. And by learning your stars, you are getting connected to the actual sky. The problem that we have with all of these smart telescopes is that you put the thing down, you say, show me Orion, and the telescope turns, and you have no idea where Orion is in the sky. You just are watching the telescope do its thing, and you are disconnected from this process. And I might just be an old man shouting at the clouds here, but I feel like if we lose that knowledge of the sky, if we don't know how to star hop, find our way around the sky, then we are losing something fundamental to our appreciation of astronomy. But again, I'm probably just wrong and old. And I understand, that kids these days just want to use smart telescopes. But yeah, Skymasters, 15 by 75. They make a 25 by 100, but they're beasts and they're very heavy. So they're great, but you have a hard time holding on to them. And then if money is no object, if you are super rich and you want to get the absolute best pair of binoculars, then I recommend the Canon image stabilizing binoculars. They come in a smaller model and they come in a larger model, and they are just so great to use because you take these things, you look up in the sky, you see something you want, and then you press a button, and then the sky just stops moving, because the image stabilizing on the binoculars is compensating for any jiggling and movements that you do with your hands. It's an absolutely amazing experience and makes using binoculars just perfect. So, but they cost $1,000, $2,000 for the bigger ones. So they're very expensive binoculars, and who knows if they're more delicate or whatever. So find a pair of binoculars any way you can. If you're using them, upgrade to a bigger pair of astronomical binoculars. And if money is no object, get a image stabilizing binoculars. Hudson Ansley, have you ever considered putting all the question show transcripts and maybe interviews in a notebook LLM that folks could query? So I don't know about specifically a notebook LLM thing, but I'm definitely working on ways to make all of the transcripts, make the question shows searchable, so that hopefully people can, if they do have a question, they can check to see if that question has been answered before. And then if they has, then they can even watch the video on on YouTube at the right moment to be able to see the answer to the question. I think that would be super useful to people, and I would love to be able to develop it. And I think before the age of like Claude Code, that was just an impossible idea. There's no way that I could ever do such a thing. And now I imagine how I would do it, and it might take me a week. So that is in my big to-do list of things that I want to be able to accomplish. And then I would love, like right now, someone will ask a question in the YouTube chat, and I know I answer that question. I don't remember exactly where I answered that question. I would need to find the video, find the time code, give them the link. Wouldn't it be great if I could just do a search for myself and go, someone asked me a question, when are we going to build the Dyson sphere? I'm like, hey, I answered that question really nicely in this episode. Here's a link directly to it. Watch that. You're set. And that would allow me to give direct answers to people in the YouTube comments, and then be able to save the ones that are the fresh new questions that I could answer in the new show. So I think about this a lot, and 2 years ago I was like, it'll never happen. There's no way we could do it. Even Chad and I talked about ways that we could try to implement it. It was going to be too much work. So now maybe it's possible. El Clarindo. Why is the L2 Lagrange point, which is unstable, preferred for placing space telescopes relative to the stable L4 and L5? So the thing is that the L2 is perfect for the job, which is that if you put a telescope out at the L2 point, then the Earth, the Sun, and the Moon are all clustered together in this very small spot in the sky from the perspective of your telescope. You're on the far side of the Earth, the Sun is lined up, the Moon is in orbit around the Earth, but at any time it's never going to be that far away from the Earth from your perspective, because L2 is pretty far away. It's more than 1 million kilometers away from the Earth, 1.5. And so you are trying to grab images of the sky, and you don't want that radiation. And so it's the perfect spot for that. And yeah, you do have to pay the price, which is that you need to use propellant to maintain your position at the L2 point. While if you went to the L4, L5, then you wouldn't have to. You could theoretically fly over there, but then you're going to have the Earth on one side, the Sun on the one side, the Moon is going to be in view. It's not going to be as good. And it's just more communication time. So the L4, L5 point are tens of millions of kilometers away from us. And so the amount of data that you can send home at the same speed is much lower. So you want this sort of perfect balance point, and that's what L2 gives us. Darth X0. Will Elon's 1 million solar powered data center shade the Earth enough to help with global warming? Ew. I mean, no, thank you. So would a cloud of satellites orbiting around the Earth with enough density reduce the amount of illumination that is falling on the Earth? Yes. But I mean, if that is your goal, there are other ways to do that. Like you build something at the Earth Sun L1 Lagrange point so that you are shading the Earth in this way that is really, really controllable. To just sort of have as a secondary thing that you are having more shadows falling on the Earth is very dangerous. And then it sort of kicks you into this place of essentially geoengineering, that you are trying to come up with a radical kind of you only live once solution to a problem that we have all of the tools at our disposal down here on the surface of the Earth to deal with. Reducing our emissions, switching over to renewable resources, sequestering carbon via planting forests by crunching up basalt and putting it in the ocean. Like, we have a lot of ways to be able to do this, and that there are unforeseen consequences for us relying on some kind of geoengineering solution, like launching various chemicals into the upper atmosphere, seeding enormous amounts of iron into the oceans to try and lock up more carbon. Like there's a lot of ideas that theoretically could solve the problem, but that they're going to have all kinds of downstream consequences. The sad state is that we're probably getting close to this place where enough countries are being negatively impacted by the results of climate change that they're going to start taking actions into their own hands, that they're going to start doing these geoengineering mega projects on their own to try and solve the problem, because the world isn't coming to agreement, especially with the actions that we're seeing recently with the US sort of pulling away and doubling down on greenhouse gases. You're going to see other nations start to come together and make these kinds of agreements to try and do the geoengineering, which is a terrible idea, right? Like this is not the way you want to do this. Whenever you think, oh, here's a simple solution, let's just block the sun's light from space. And then, oh, turns out, we weren't getting the right wavelengths and our crops are dying. Oh, it turns out, right, there are all these unforeseen consequences. So, and you would need a lot more, and they would need to be bigger, and they would really be purpose built to block sunlight. 1 million satellites is nothing compared to the amount of radiation that's coming into the Earth. Paul Wilson, do the Voyager probes look weathered from their space journey, or do they look clean like new? It's an interesting question. And like, obviously we can't know the answer to that question because we can't see what the Voyager spacecraft look like. Now we can see that spacecraft there in low Earth orbit do look weathered. We see little sort of pits and pockmarks and things from bits and pieces of debris we know there's a ton of even just like small, like 1 gram pieces of material that are in orbit around the Earth. Some of it is from space, much of it is human caused, and this causes a weathering that happens to any spacecraft. Whenever you see, say, the space shuttle, there were like pocks and dings in the windscreen. And some of them are like a little concerning. And when you see the solar cells on the International Space Station, same thing. You see little pockmarks and dings and blemishes from the various space junk and just micrometeorites and stuff that have hit the station. And we know that the James Webb is being hit by small micrometeorites. One was fairly big and in fact caused people operating James Webb to kind of change its orientation just to minimize the number of those hitting it. And so the Voyagers have been going for 50 years. They have absolutely gotten dinged and hit by various stuff. And if you could look at them, you would see that, in addition to the constant radiation that was coming from the sun that has probably bleached any paint on the surface of it. And there was, like, the amount of weathering, though, is very low. And it's been estimated that the Voyagers, like, you could still read the records on the Voyagers 1 billion years from now. So it's going to take on the order of billions of years for these things to fully weather in space to the point that they're unrecognizable blobs of metal that are drifting through space, as opposed to, like, that clearly was a robotic spacecraft once, one long time ago. But yeah, if you could look at the Voyagers, they had some wear and tear for sure. Mr. Spaceman, how screwed up is our economy that placing data centers in space is the best option? I mean, I think we all have experienced how screwed up our economy is. Regular people are seeing inflation rise. They're seeing various costs go out of reach. Things like being able to buy a house, the cost of being able to get an education. I mean, the costs are rising and rising. And although, theoretically jobs are rising in some cases, that in some places costs of fuel, things like that may be going down. Electricity costs are going up. RAM prices for my upcoming Steam PC, Steam OS, Steam box. Wait a second. What's it called? Steam Link? No. Steam, not Steam Deck. Please, someone help me. Steam box. Steam machine. There we go. Oh, God. Okay. The RAM prices are going up for my upcoming Steam machine. It's crushing regular people. And so we absolutely see that that the economy is in a very weird state. And now we're seeing, for example, that hard drive prices, SSD prices, GPUs are locked down for like years at a time now, that like regular people aren't going to be able to just buy these things, and there's like no relief in sight. And so right now, the entire economy is being propped up. The stock market is being propped up by the speculation in artificial intelligence. Is it a bubble or not? Now, I am a child of the dot-com bubble. I was there right on the front lines when the dot-com bubble crashed. I was in a company that was building websites. We had a ton of interest leading up to March, the year 2000. And then it was like the bottom dropped out and we saw just carnage across the landscape. And the internet is a thing, right? Like we were all working on the internet, and here we are 25 years later and 26 years later, and the internet is as more popular than it ever was. Like, imagine how you would feel if I took the internet away from you. You would not like that. And so the reality was that the internet was going to be a gigantic, make an enormous difference. It's just that people didn't want to. It wasn't a good valuation to send kitty litter by mail to people. So things were overvalued and things crashed. And there was a ton of infrastructure that was built out with the dark fiber that eventually found its use. And in fact, we have this internet that we have today thanks to the sort of overinvestment by the tech firms 25 years ago to build out all of this infrastructure, lay all this fiber that we now take advantage of. And so it's the amount of money that's being spent on AI today dwarfs the AI, or the amount of money being spent on AI today dwarfs the amount that was spent during the dot-com crash. That was adorable compared to the investment that's happening today. And that there are very few ways out. And the ways out are almost catastrophic. Like the one possibility is that this is a bubble and the stock market crashes and everybody's 401ks and RRSPs, as we call them in Canada, take an enormous hit. Your investment is stalled out. You're not able to retire for a decade, sort of like what happened with the lost decades in Japan. Like that's one possibility. The other possibility, and maybe more terrifying, is that it does work out, that they are correct and that AI goes on to consume all of human labor. And then how do we have jobs? Right? Like I've mentioned this on many times that I am one clever AI away from being utterly unnecessary to you. Like I know you appreciate the fact that I'm an actual human being and I'm here relaying space news, but come on, you could be chatting with ChatGPT or Claude and be giving some interesting answers, and telling you that you're absolutely right and sort of helping you, confirm your wild theories about the cosmos. I joke, but I only exist right now because the AI is not as good as me yet. Later on, I will exist because the AI, because you have a sort of nostalgic memory of me providing space news, and you sort of keep me around like a pet. But sending data centers to space, which sounds crazy, is not entirely crazy. That the amount of money that is being spent, the energy that is required, the resources that are required are in the hundreds of billions of dollars per year. Today, they will be trillions of dollars. If this thing works out, they will be in the trillions of dollars in the future that I have experienced both the pluses and the minuses of how quickly AI is gobbling up every part of our lives. And it is not, I can imagine scenarios where it just keeps going. And that, in fact, sending a dedicated computer to space, that all it does is spends a year crunching a bunch of data, and then at the end of that year sends you home a gigabyte of information, that is actually an efficient use of space resources, that it gets those data centers to stop gobbling up rivers and streams and pumping out pollution with coal plants and natural gas, and puts it out into space off Earth. And then all it does is sends the work home. And that enough people who are serious take this seriously, that I have to be open to the possibility that this is the direction that it's going to go. And the child space nerd in me says, yeah, right? Like, what did you think becoming a solar system spanning civilization was going to look like? You came up with a reason, you went to space, you then built out your space infrastructure, and then you set up on the moon, and then you went to Mars, and then you went off to other stars. Like how would that happen? Right? And then the part of me that's actually living through the transition goes, this is all really gross, and I don't like it, and I don't like the way this is going. And as a person with a computer science degree who is deeply enmeshed in all of the ongoing developments, I understand this very well. And we don't know how this is all going to play out yet. And all we can hope is that at some point saner heads prevail, that the countries put regulations in place that make this not become another tragedy of the commons. And like the cynic in me and the cynic in you, I'm sure right now is just yelling at the TV or the phone or whatever, you're listening to your podcast, you're going, of course they won't. Of course they will take their eyes off the ball, and the capitalists will build things that cause a negative impact on the rest of us, and the disparity between the rich and the poor grows ever wider. And now suddenly there are no more rungs that you can climb, that human labor is no longer necessary, and that really it's just the accumulation of capital. Like, this is a possible future that we face. And then what are the solutions to that? Is it, that there's some kind of living wage that's provided? Is it that the fruits of the AI companies has to be distributed amongst the populace? Who knows? But it is a very, very weird and a weird future that is running at us headlong, and we don't know how this is going to play out. And I don't think that you should not be overly cynical. Say, this is just ridiculous. It's just another bubble. None of this is going to happen. Like, anybody who's worked in code, and I'm sure like anyone who's a programmer, anybody who has a computer science degree has experienced the change. And it really took hold in the last maybe 3 or 4 months that you went from AI's dumb, right? Like, it just makes a lot of bugs and I don't like it, to, oh God, like this, like I am imagining things. I'm sending a swarm of agents out. They are delivering this thing, and it works better than I could have possibly imagined. And I don't need to code anymore. Like, that is the change that has happened. And so that's on the one hand, you have to be open to the possibility that these things are going to happen. But at the same time, you can't be overly, sort of excited about it. You can't say, well, this is all great and there's no problem. Like, foot on the accelerator. Let's go full speed. What could go wrong? YOLO. No, all kinds of things can go wrong. And we are experiencing all of the things that can go wrong, from it affecting people's mental health states to people getting bad advice, to through excessive energy use, diminishing resources, putting pollutants into communities, to crushing people's job prospects, to all the way up to existential issues. The potential extermination of humanity is on the table. And, if you want to see my thoughts on that, I've got a whole interview that I did on Doom Debates where I talked to Liran Shabira about, my perspective on that. And we mostly talk about space and stuff, but we also talk about sort of my P-Doom. And I think that it comes kind of back to this, which is that the flaws in our economy, back to your original question, Mr. Spaceman, the flaws in our economy, the flaws in the way we've done things are now magnified, accelerating, and hopefully someone can put the brakes on to at least give us a chance to digest what is one of the most dramatic changes in human history in a way that minimizes its impact on the planet and on us as people and the future of humanity. Whew, that turned into a rant. You never know. Daniel Guite. Do solar winds influence planet orbits? Theoretically, yes. I mean, you have particles that are coming from the solar wind at hundreds of kilometers per second. They are impacting a planet like Earth, and they're imparting a teeny tiny little bit of momentum. But the mass of the Earth is so great, 6 times 10 to the 24 kilograms. It's huge. And so the amount of momentum that is being delivered by each one of those particles is minuscule, and that you would have to go the entire lifespan of the sun times many, many, many to make even a teeny tiny fraction of changing the orbit of the sun. Oh, sorry. You'd have to spend trillions of years with that kind of solar wind to make any significant change to the orbit of the Earth. But smaller objects are influenced by the sun, both by the solar wind. And so you think about, there are these small particles. They're a kind of micrometeorite, where the micrometeorites are so small that they are carried out by the solar wind out into deep space, and they're gone. And that, you've got asteroids that are crashing into each other. They're producing smaller pieces of debris. They're also producing clouds of these tiniest pieces of debris, and they're light enough that the solar wind can just accelerate them out of the solar system. And so, and then you have another thing that's kind of cool called YORP. And I forget the acronym, and I apologize, and you're probably just going to want to cut this, but just the radiation coming from the sun can move asteroids around. That the asteroids, as they're turning, they're heating up in sort of unbalanced ways, and the heat causes photon pressure coming off of the asteroids that causes them to move around like thrusters. And so you can end up with asteroids spinning faster, slower, or even changing their orbits because of just radiation that's coming from the sun, that's heating up the asteroids, causing them to have little photon thrusters on them. Zoliseb. How many stars went supernova before the formation of our current solar system, and what types of stars were they? I mean, from the Big Bang until now. So we have no idea how many stars went supernova to get to the point where you had enough heavier metals that you could form something like the solar system. It's believed that a star like our sun was possible to have formed about 8 billion years ago, 8 to 10 billion years ago, that there was enough supernova generations. You had a large star, detonate a supernova. You had neutron stars collide, produce a kilonova. You had just the general winds blowing off of stars as they were dying. You're putting this material out into the, red giant stars were blowing out winds of material that had heavier elements in them. And then it wasn't until about the, say, 5 billion, 7 billion year mark of the universe that a star like our sun, planets like Earth could actually start forming. And a lot of people consider that to be sort of the start point of when you could have had abiogenesis, that you could have life in the universe was limited by that point when you could have those heavier elements. And that's still a couple of billion years before the formation of the sun. So, we always ask with the Fermi paradox, where's everybody? Are we first? Well, we're not as early, with the sun being 4.5 billion years old. We're not as early as this process could have been possible. But we do have some interesting specific examples of supernova that were continuing to enrich the solar nebula. And so astronomers have done examinations of meteorites from space, and they've found evidence of a kilonova that went off in our vicinity probably about 10 million years before the solar system formed, and enriched the solar nebula with material from that kilonova explosion. And like, not very much. When you sort of imagine your body, like a third of one of your eyelashes came from one kilonova detonation in our vicinity, say within, a few dozen light years of us, that enriched the solar nebula to produce a bunch of heavier elements, the gold, the iron, the gold, platinum, radioactive elements, things like that, the kinds of elements that we see in the kilonova explosions out there in the universe. So we can never know how many generations of stars made us. And it's not just stars. Like, there could have been heavier elements that were forming in the accretion disks around supermassive black holes that were blasting out into space as well. So there's a lot of nucleosynthesis that went on to create the perfect conditions that we have here on Earth. Thank you for the donation, Mad Million. And I will answer that question. Not because you donated. No, it's just a good question. Mad Million. The extremely large telescope. What breakthroughs do you expect from it once online? Oh, man. So the extremely large telescope, this is a ridiculously big telescope. I know it's called the extremely large telescope, but I think it should be called the ridiculously big telescope. And of course, this is when we showed the XKCD comic about all of the future telescope names that are hilarious. It's a 39-meter telescope that is being built in Chile right now. And when you compare, like, the biggest telescope on Earth, there's a telescope in the Canary Islands that's 10 meters across. The current, essentially most powerful network of telescopes is the Very Large Telescope, which is a collection of 4 8.2 meter telescopes, as well as a couple of other smaller telescopes. This thing, there's the Large Binocular Telescope that is 2 8-meter telescopes side by side. This thing is just ridiculous, 39 meters across. And it's under construction now, probably will be finished construction 2027, 2028, and then it should be able to come online. And it is going to be like a general tool for astronomers. It's got a bunch of really interesting instruments on board. It's got this enhanced version of the adaptive optics system that we see on the smaller telescopes. And I love sort of when you see animations of what this thing is going to look like. There are all of these lasers pouring out of this observatory. And so it's going to be able to generate multiple guide stars in the sky in the field of view that it can use to then adapt the mirror shape to compensate for the atmospheric distortions. And so it will be as if it is in space. It's as if we launched a 39-meter telescope and we put it out into space. which is incredible when you consider James Webb is 6.5 meters. Like, this is a monster. And it will be so good that it will be able to do things that astronomers have just like hoped for a long time. Like, it should theoretically be able to distinguish an Earth-sized world orbiting around a sun-like star in perfect conditions. It should be able to detect the presence of gas giants and things like that orbiting around stars more like the sun. And then it would just be used in this way that all telescopes are used, to examine galaxies, to examine protoplanetary disks, see new regions forming around them. It's going to be able to, it's just like, what do you use a kitchen for, right? You use it to prepare all food. And so this thing is going to be able to be used for everything that astronomers need visible light telescopes for. It's going to be a monster. I cannot wait. And it's kind of interesting to see, like, the budget of this telescope is a little over €1 billion, like €1.5 billion. And you just compare that to the prices that it's cost. James Webb was $10 billion US dollars. Other telescopes are in the multi-billions of dollars. And yet these gigantic monster telescopes are reasonably priced. And so it just shows you the advantages of building ground-based telescopes compared to space telescopes. That said, here we are in this era where there are now, 10,000 satellites, that the field of view is getting dimmed every day. And that we might get to this point where there's 1 million satellites in orbit around the Earth. Yikes. So unfortunately, the utility of ground-based observatories is growing less and less every year. One of a mind rocks. What happens when we see Voyager coming back from the other direction? I recently watched Star Trek, the motion picture, and, like, spoiler alert, but you've had 50 years to watch this movie, that they find this enormous alien probe that's making its way through the galaxy to Earth and is destroying spacecraft as it comes, and the refitted Enterprise goes out to meet with it, and it turns out that it was a future version of Voyager. I forget which Voyager 10 or something like that. And it has been given the purpose, the task of discovering whatever it could and then returning to Earth with all the information that it could. And it was met by some machine civilization that sort of latched onto it and took on its purpose as their own, and now it is coming back to meet the creator. And when I first watched the movie, I was 8 years old. My parents were big Star Trek nerds, and they took me to go see Star Trek, the motion picture. They also took me to see 2001, and that didn't work out so well. I was very scared of that movie. But I got over it. But anyway, so we went to go see Star Trek the Motion Picture, and it really, like, I didn't like it. It was sort of scary and made a lot of sort of loud noises that I didn't enjoy. And then I recently watched it, and it's beautiful. It's just a beautiful movie. And I think it's the best Star Trek movie, which is a very weird thing to say. I know. Wrath of Khan is probably better, but still, Star Trek 1, is really special. And when you watch it again, I think with fresh eyes and sort of just take in the kind of the slow nature of it and sort of sense the character arcs that they're defining about Kirk and Spock and all of this. It's a beautiful movie and deserves to be up there with all of them. But anyway, Voyager returns. So that's one possibility, is that the Voyagers get picked up by some alien civilization. They take on their task of exploring space, and they bring them home, and they potentially destroy the Earth unless we can mount a spacecraft to go out and meet with them and help understand them and merge with their consciousness and talk them out of it. The other possibility, and the one that I think you're probably suggesting, is that the universe wraps. That if we go off in one direction long enough, maybe we'll return to our starting point. And that is not crazy. Now, it is crazy on the timelines of what the Voyagers could do, that it will take 50,000 years for the Voyagers to be able to reach the nearest star system. This is a very, very slow way for us to move out into the cosmos. But that one of the possibilities is that the universe that we live in is finite, that it is not infinite. And if it is finite, then in theory, if you send out a light signal in one direction, or if you look with a telescope in one direction, if the telescope is powerful enough, you would be able to see yourself from behind, which would be super weird. But from what we can tell, if the universe is finite, it is bigger than the universe, the observable universe, the universe that we can see, right? That the universe has been expanding for 13.8 billion years. The actual size of the universe, the diameter of the universe, is about 93 billion years today. And that when you measure the flatness of the universe, try and get a sense of, like, is space curving it back on itself, then it is vastly bigger than what we can observe, probably in the thousands of billions of light years across. Like what we see is like 2 or 3% of the actual universe, or it's infinite. Like, you can't tell the difference between whether it's bigger than we can observe or it is infinite. Those two are identical from our perspective. But if it is finite, then one of the sort of things that would happen is that if you would travel in one direction, say you build a warp drive, you travel in one direction in a straight line, you would return to your starting point because the universe would wrap. So maybe in a few quadrillion years, the Voyagers will return to the starting point. One of mine rocks. Did Kessler syndrome hit the Chinese space station? Did something happen to the Chinese space station? Not that I could see. Wait. Oh, the space debris. No, okay, so you're probably talking about space debris that hit the station back in November. And there's just like space debris hit the International Space Stations. There's space debris up there, and the Chinese space station, the International Space Station have to take evasive maneuvers from time to time to avoid getting hit by a potential piece of space debris. That is very different from what the Kessler syndrome theoretically would be, where chunks of spacecraft have hit other spacecraft that have turned into this sort of shield of metal around the Earth. No, we have not begun the Kessler syndrome. We are just in the pre-Kessler syndrome days. Enjoy them while they last. Stephen Lewis, everything is spinning. Is the universe spinning? So everything does spin. And, obviously we're here on the Earth is spinning, the sun is spinning, the solar system is spinning, the Milky Way is spinning, the local group is spinning, the Virgo supercluster is spinning. Really everything within the universe is spinning. And so one of the questions you might ask is, well, like, what about the universe itself? Is the universe itself spinning from some outside observer? And what's interesting is that is a thing that you could tell. Like, if you were alone in the entire universe and you were just spinning in place, you would feel it, right? It's not a relative thing that, we measure motion in a relative way. If I'm in a car, you're in a car, the cars are going side by side each other. Your movement compared to me is zero because we are driving down the highway at the same speed. But if you're in a car that's coming in the opposite direction, then you see you add your velocity to my velocity, and then you measure that difference in velocity. And so it was all dependent on the observer. But when you when you rotate, when you spin, that is independent, that you experience these forces, and it doesn't require any kind of relative perspective on that. And so one of the possible explanations for the for the Hubble tension, that the measurements of the universe seen in the cosmic microwave background radiation is different from the measurements in the universe seen in supernovae, in Cepheid variables, is that the universe is spinning, and that this sort of independent spinning is then causing the universe to move at different rates away from us at different points in time. And there are papers that have proposed this. And they say that the amount, you can literally measure the amount that the universe is spinning based on the Hubble tension. But it is not the mainstream scientific perspective. And there are all kinds of problems with making a sort of gross generalization on that. You know, anytime you come up with a scientific theory to try and explain something that is happening, you have to explain all of the existing evidence. You have to solve current observations that have no answer, and you have to make predictions that can then be tested experimentally. And so there's a lot of ideas that would explain something, but then it doesn't explain the other things. And if it doesn't explain the other things, then you have to reject it. And so a lot of these ideas come up all the time, and then people try to fit their models to try and explain the other things, and it doesn't fit and it breaks. And the scientific community tends not to adopt it. The lambda CDM model is the one that explains all of the observations that we see in the universe, and has done, you know, is the one that has done the best. And so that is the one that most astronomers agree is correct. Jimiro, isn't there mold on the space station? Like a lot of it? Yeah, so there is definitely mold on the International Space Station, and this is because you've got a closed environment that has human beings that are breathing out water vapor. The water vapor collects on various surfaces in this environment that has, you know, no gravity, has weightlessness, and then it's warm, right? It's always warm inside the International Space Station, and that is the perfect environment for mold to grow. And so the downside of being an astronaut, and this is like the unromantic part of being an astronaut, is that you spend a lot of your time in maintenance on the station. They are constantly cleaning, wiping down surfaces, testing the air quality to make sure that it's safe for them to be able to breathe. And they have to deal with these kinds of issues all the time. And that astronauts spend a huge chunk of their day exercising, cleaning, maintaining equipment, just to then be able to spend half an hour doing some kind of science experiment, or watch a DVD, or enjoy a meal with their comrades before they pass out and start the whole day all over again. That it sounds glamorous. Yeah, you do get to look outside the window in the space station, but the downside is that you're constantly trying to maintain this complicated machine that is flying in orbit. And there's been a ton of really interesting research about the kinds of life forms that exist on the space station. That you have this laboratory where you've got bacteria, you've got mold, you've got other organisms that have gone to space with the astronauts and are now living on the station. They're exposed to different kinds of radiation. They're experiencing weightlessness, and this is causing their genes to express in different ways, different kinds of advantages and disadvantages, because it's an evolutionary environment. And they're constantly bringing samples back home to Earth and analyzing them and studying them and finding the new things that they do, and then trying to run experiments that actually maybe put those things to use. They're finding like various antibiotics grown in space have different behavior, or bacteriophages grown in space, which are viruses for bacteria. They have different advantages against different kinds of bacteria than the ones that are grown on Earth. So the downside is, yeah, you have to clean up mold. And I think, from what I understand, being on the station, it smells very musty. It smells like you're inside a locker room, despite the best efforts of the astronauts to keep the place as clean as humanly possible. Probably smells like bleach and locker room. Stanton 415. Can we quiet the CO2 crazies with new nuclear power on Earth? So I don't know what you mean about crazies. You mean, can you offer a method of power generation that the scientific community, the 97% of the scientific community that agrees that human released greenhouse gases are raising the temperature on Earth and it's going to have consequences for humanity? Are those the crazies? As opposed to the companies, the oil companies, the greenhouse gas polluters, which are doing enormous amounts of lobbying to try to create a schism between regular people so that they can delay the absolutely natural and now profitable transition to renewable resources. When you look at the cost of solar power and windmills at this point, it is by far the lowest form of power generation on Earth, that you literally have to hate money. You have to hate profit to build a coal plant, to build a natural gas plant, to build, to use oil, to, that if you want to generate a bunch of electricity in some location, you build solar panels. It is ludicrously inexpensive. You can go online right now. You can buy tons of watts of solar panels. You can deliver them to your house. You can install them. You can decrease your reliance on your power company for a fraction of the price that you're going to have to pay. And you will pay that money back and you'll be putting money into your bank. We have entered the era when renewable resources are the way to go. The downside of solar panels is that they don't work at night. The downside of wind power is that it doesn't work when the wind doesn't blow. We have a solution to that, which is batteries, right? You hook up your solar panels to your battery. The batteries, I have one in my house. And I don't have solar panels in my house yet, although we're really planning to because I love solar powers. But anyway, so you, during the day, your solar panels collect energy and then you put it into the battery. And then at night, you trickle the power back out of the battery and you now have baseload power. Nuclear makes a ton of sense. And I think, we went through this era where everyone was panicked about nuclear power. You saw, obviously, they've been used for nuclear weapons. We saw 3 Mile Island. We saw Fukushima. We saw Chernobyl. Like, we know that nuclear reactors are risky, can be risky. But there is a whole new generation of nuclear power plants that have been developed that are dramatically safer, that use, in some cases, leftover waste that's been used by other reactors. It's a revolution. And I think it was a terrible mistake to take our eye off of the nuclear power track and potential, that they have their place. They provide baseload power. They can be a compact energy source. You can deploy a nuclear reactor in places where you just can't deploy solar power, like at high latitudes or places that don't get a lot of sunlight or places that don't get a lot of wind. Like, there's a place for nuclear. The problem is that building a nuclear plant is a very complicated affair. It takes a lot of permitting, takes a lot of time, takes a lot of investment to actually be able to build these things out. Solar panels don't. You literally go on Amazon, order a bunch of solar panels, hook them up, get an inverter, boom, you've got solar power. So, and this is what you're seeing, while China is, for example, the largest emitter of carbon dioxide in the world, with the US being number 2, their adoption of solar power and renewable resources is mind-bending. How much? Like, they are adding more solar power, more renewable resources to their grid than vast percentages of the rest of planet Earth. And it's expected that they will wean themselves off of fossil fuels within a few years and start the decline and eventually, get to some, usable minimum. And they're producing a ton of nuclear reactors because they have their place. So I think we accept the fiscal reality that renewable resources are the best way to power our civilization. We build nuclear plants where they are appropriate and they form a mix in our power grid. And we get off of burning fossil fuels as quickly as possible. There's a great video by Technology Connections where he goes into that and makes the case very strongly on why we should be transitioning as fast as we can into that renewable future. And I love, like, I have an electric car. I love it. Right. It's inexpensive to power. I never go to a gas station. It's the best. Quiet the CO2 crazies. Embrace the CO2 crazies. Listen carefully. Evan.pro, you mentioned the large binocular telescope. Would there be much advantage to making a DIY smart telescope system like you've been building, but for binoculars with 2 image sensors? Oh, man. Don't threaten me with a good time. Yeah, that sounds cool. So binoculars are fantastic. And but the thing that makes binoculars fantastic is actually something about our biology, that our brain works best when we are bringing in signals to both of our eyes. That, and you can even do this, like look at something that you have trouble reading with one eye and then switch to the other eye, and you will see just like sort of what is the state of your eyeballs, right? And yet, if you look with both eyes, you can see it, you can read it, whatever. And there's this sort of combined magic of the two eyes. And that is part of why binoculars are so wonderful, why you want to use both eyes at the same time instead of using just a single telescope lens. And so people have built binocular telescopes, and there's some incredible builds that people have put out on, you can find them on the internet. There was a company we featured, or a guy actually in Oregon, I think, who is like built a kit so that you can use a 3D printer to build all of the mounting components for a binocular telescope, and you get 2 identical, say 70 millimeter refractors. You mount them together, and then you have 2 eyepieces, and then you look through this telescope. And I've never looked through one, but I hear it's wonderful. And I've even seen ones where people have this like chair, like a recliner where they sit in, and they've got like a joystick that allows them to move around, and then this huge pair of binoculars that sort of focus into their eyes, and they sit in this. It looks like the I don't know, the gunning seat in the Millennium Falcon, except you're using it for looking into space. And that's really cool. I don't know if I don't know if having binoculars for a smart telescope is going to be something that you would want to do, because you have the additional complexity of merging the light from 2 separate telescope images into one that you can then display. But who knows? Maybe someone is going to decide, yeah, that's the way. You have 2 telescope lenses on the side of your smart telescope, and they work in tandem, and they combine their light together, and they give you something that is better than what either one of those lenses would do. And maybe the lenses are on either side of the telescope, and so you get a kind of a bigger baseline. But the dream is always like, could we build an interferometer? And the problem is that just interferometers are very complicated to build, require a level of precision that you just can't build in a piece of consumer electronics. And so I think this is why we don't see people use binocular telescopes, apart from visual astronomy, where just the meat computer that you're using really appreciates signal coming into both of its meat cameras. Stephen Lewis, shouldn't we be sending robotic scouting and landing site preparation missions to the moon now instead of rushing to send people? One death would be a major setback. Well, of course. Yeah. I mean, this is happening. I mean, that we have the entire NASA commercial lunar system where they are paying various commercial companies to deliver scientific payloads to the surface of the moon. And, you know, this is something that used to be done by entire space agencies. And now NASA is, you know, the budgets of these spacecraft is very low. You think about the Blue Ghost, like the budgets are in the tens of millions of dollars to deliver a payload to the surface of the moon, which once cost $1 billion. So we're in this new era, and in preparation for the Artemis mission, which in theory is going to land humans on the moon in 2027, but come on, or the Chinese are going to land humans on the moon by 2030, that you're going through the process of the robotic testing. I think, you know, the Chinese one is probably a better example to sort of show how this is being done in a very painstaking manner, which is that, you know, the Chinese are up to Chang'e 5. They've sent several landers to the surface of the moon. They started with just a simple lander, rover, and then they went to sample returns and more sample return from the far side of the moon. And now we're moving into in situ resource utilization on the surface of the moon, leading up to humans landing on the moon. That all of the technologies are the same. You have a big rocket, it carries a payload to the surface of the moon, lands safely, people do some things, they get on their ascent vehicle, they meet with their capsule, they come back down to the Earth. This is what happens with the sample return from the moon for the Chinese spacecraft. And so, you know, all of these steps, all of the uncertainty, all of the risk that you're describing in your question are the kinds of things that people who are doing mission planning are thinking about. And that whenever human lives are on the line, you need to take that very seriously, and you need to be more careful, and you need to flight test the hardware that is coming before that. And that's, you know, and that's why I think I made my skeptical come on early on in this question, which is that the US plan for sending humans to the moon is going to be relying on the SpaceX Starship as the human landing system. But we still have not seen Starship go to the moon, land safely, go back into orbit, demonstrate that it can be the landing system. Now, it probably can and probably will, but it's going to take some stages and some steps and some development. And then you're also seeing Blue Origin go all in on its lunar landing plans, but they have not demonstrated that they can send their lander to the surface of the moon yet. Like, this is all theoretical. And so if NASA, if the US's plans to land humans on the moon is depending on hardware that has not been flight proven, not demonstrated to do the job that it's required, then we will expect delays. But we have learned from the history of human space exploration that whenever you cut corners, whenever you ignore the obvious warning signs that your spacecraft is not ready to go, then you risk a potentially deadly result. We lost 3 people in Apollo 1. We lost 7 people in the Challenger. We lost 7 people in Columbia. That is a lot of people to lose in just trying to go to space. And any deaths, any injuries will cast a long shadow over the future of lunar space exploration. Mr. Spaceman, why do star generations count down from population 3 to population 1? Do you expect any new generation stars beyond after population 1? So the reason is because originally there were only 2 populations of stars. There was the population 1 stars like the sun, and then there were the population 2 stars that were older than the sun. And it makes sense, right? Like, why not? So generation, we're the population 1 stars, the ones like we're at the top of the evolutionary metal collection of stars, and then there's the other ones that are the next down, which are metal poor. And then astronomers realized that there would be this original primordial star that was formed from just the hydrogen and helium with no other metals mixed into it, and so they called that population 3, and that's why they had it. So that worked, I think, although I see it reconnecting right now with a 227 second 28. Yeah, so looks like it's no longer bringing in live questions at the same rate. But and I see a lot of people retracting their messages. Zapfan, how did that work for you? Audience, how do you like this? Me having putting the question up like that. We haven't even gotten to the point where I display pictures, which is coming. So, for example, I apologize to use your question, Frank. I'm not going to answer it, but I can put up of course it doesn't display at the right size. Okay, I'll figure that out. But I can put a lunar eclipse up there. Yeah, I think for me cognitively, it works out pretty well. So I'm able to pick the questions, answer them, and focus on just trying to be as present as I can for the questions. Like I think a thing that really bothers me about a lot of live streams when you experience them live is that the host is trying to juggle a lot of things, right? And so and it depends on their level of ADHD, I guess, is how well they can kind of juggle those things and how well they can focus on the task at hand. And when I think about the kinds of live streams that I watch, or when I watch a Twitch stream or whatever, it's rambling. There's a lot of delays. And then people make these videos where they compress all the good stuff into like a VOD the next day. And I want to try and figure out how to be able to self-produce something that is rapid-paced, focused, without requiring an enormous amount of editing for you to be able to just watch it, as a VOD. And so hopefully that's how that worked. But please let me know how this worked out for you, and whether this is, whether this format made an improvement. For Zapfan, I think we got it. I think we were able to kind of struggle through the entire episode and not have to rely on the old system, which is kind of exciting. I see some bugs still that I'm going to have to sort out, but thank you for being on deck and on tap. And for those of you who are watching this, I have to give just an enormous thank you to Zapfan and John Suffel, who hasn't been around recently, Arjone, other moderators, but especially Zapfan, who week after week after week showed up and helped me moderate and select the questions to go into the database so that I was able to answer them. That the show was markedly worse, dramatically worse, without Zapfan's help whenever I had to sort of fly solo. And so hopefully Zapfan gets to take a break now, that you can come and enjoy the show or not, and not feel like you're going to be letting me down and letting people down if you don't show up. So please, everybody, give Zapfan a huge thank you from the bottom of our hearts for all of the work that they've done for a couple of years now in helping make this show run. We really appreciate it. And hopefully we're in a new era. And and let me know. Yeah. Right on. Okay. Well, and that said, I think I'm going to wrap things up. We've got Astronomy Cast in an hour. So if you want more Fraser, asking questions of Dr. Pamela Gay, Astronomy Cast starts at 11 o'clock Pacific time, and we have to get 2 shows done. So we're going to record the 2 episodes back to back in the same show. So it's probably going to be like 90 minutes long. So I'm going to be last streamed out at that point. But still, I really enjoy this. I hope it comes through. that for me, this is just a pleasure and a joy. And I really enjoy interacting with all of you guys. And I look forward to a new interview probably coming out today that I hinted at. I should have some clear skies in a couple of days, Wednesday, Thursday. It's snowing right now, but I will try to do some live streams with the new telescope setup the second that I can. It's going to be monochrome, but I think you'll get a sense of how cool it's going to end up being. All right. Thanks, everyone. And we'll see you all next week or in a couple of days. Who knows?